Okay, you guys have the sheet out? Gotta have this sheet out. Okay, it says as follows. Many triangles are not right triangles. We've learned that, right? If you have, you need this sheet. Hold on. Okay. Time to focus. This is a hard lesson. So, many triangles are not right triangles, but they're oblique triangles. And if they are right triangles, we can use just our general SOHCAHTOA principles. We can write that down. We'll write, if they're right triangles, we can use SOHCAHTOA. And you can also use the Pythagorean Theorem. All right? So, what if you don't have a right triangle, though, we use the law of sines. Straightforward, right? And you guys saw from your sheet that you can have one solution, you can have two solutions, you can have no solutions, and that's what you should have practiced. Now, I can tell by the number of hands that went up of people who either aren't done with their assignment or haven't started yet, we're getting a busy time of year. Yep. Again, it's the life you chose. You got to stay up on it. That's all there is to it. So if you really want to make sure that you know the stuff, get going. So the reason why I think that this test was harder for people last year was because they probably got behind in some of their homework. What's up? SOHCAHTOA. So right triangles, Pythagorean Theorem, law of sines. You can solve a lot of triangles, but in the law of sines, you're required to have an angle and its opposite side. What if you don't have an angle and its opposite side? What if it says, what about triangles where we are given all three sides but none of the angles? What about triangles where we're not given an opposite side, where we have two sides and the included angle? So what do you do in those situations? Okay? Look at your chart real quick. All right? Again, you see angle, angle, angle. No solution. We can't prove that they're congruent. Two sides, or two angles and a side, that's enough to show congruence. Use law of sines. Side, side angle, you follow it down, you decide the side opposite, the angle is shorter or longer than the other given side, you decide if there's one or two solutions or zero solutions. So what we're talking about today are these two scenarios. And we need to say something interesting about triangles where you're not given an angle and its opposite side. And so what we're going to do is we're going to derive some formulas. And this takes a little while, but your participation is key to your level of understanding. We'll call this side A, we'll call this C, we'll call this B. So this is side A, this is side B, this is side C. Many times in triangles we are given the angles or the sides, but we're not necessarily given the heights. We like the heights because they make right triangles. And when they make right triangles, we can use SOHCAHTOA, Pythagorean Theorem, all sorts of stuff like that. So if I want to say something interesting about this triangle, I'm going to draw a height and see what I can come up with. Okay? Good boy. So, angle A, opposite side A. Angle B, opposite side B. And you can see when we paired H with B and H with A, well, we use the law of sines for that. Well, what if we're not given an angle and its opposite side? What if we're given like A, and then we have side B and side C? Well, that's really complicated because side C, you can see that's divided up into two segments. I'm going to divide those two segments up. I'm going to call this one X. I'm going to call this one Y. What's the relationship between X and Y and C? X plus Y is C, so that means that Y is equal to C minus X. Is everybody okay there? All right. In hopes to say something interesting about the rest of our triangle, what I'm going to do is I'm going to try to relate these together, okay? So you can see that one triangle has an H and an X, right? Another triangle has an H and an X. Let's use the Pythagorean Theorem to write two expressions. Namely, one would be X squared plus H squared is equal to b squared. Let's grab the other one. We would have c minus x squared plus h squared is equal to a squared. What do you think of that? You okay? Everybody okay with those two expressions? What do those two expressions have in common? H squared. Let's solve for h squared in each situation, and then we'll be able to substitute. H squared is equal to b squared minus x squared, and h squared is equal to c minus x quantity squared. Oops, sorry. A squared minus c minus x quantity squared. Everybody okay with that step? If they're both equal to h squared, I can set them equal to each other. If they're equal to each other, I have b squared minus x squared equals a squared minus c minus x squared. Everybody okay with that? So I just got rid of what? H squared. And again, if we're trying to say something interesting about triangles, I would like to only have A, B, and C in my formula. Because we're not going to be given X. We're sure is not going to be given H. So I need to now get rid of my X. In attempts to get rid of the X, I'm going to square this side out and see what happens. I'm going to write out B squared minus X squared equals A squared minus what? You do the math. I already know how to do it. What do you give if you square that out? Got to FOIL it. So if I take c minus x and I square it out, I get c squared minus 2cx plus x squared. If I FOIL that out, that's what I'm going to get. And I got to distribute my negative sign through, and I get negative c squared plus 2cx minus x squared. Piece of cake? All right. We're almost there. What do you notice? What do you see? X squareds? Yeah, you could add an x squared to both sides, couldn't you? If you do that, they go away. She's so loud. So now I have b squared equals a squared minus c squared plus 2c times something. Wouldn't you agree that I should have something instead of that x? I mean, we said we wanted to get rid of the x altogether, right? We've almost entirely got rid of the h's. I got rid of the x squareds. Now I just got to get rid of the x. I got to say something intelligent about x that involves a, b, and c. This is not called the law of sines, but the law of cosines. Where's x? Can you say something intelligent about x that also involves this and this? Hint. Hint. It's called the law of cosines. Right? So I said something about x in terms of a and b. Can you now solve for x? Well, sure. We could solve for x. Multiply both sides by b. b times the cosine of a is equal to x. So now down here in my formula, I can insert b times the cosine of a. I'm going to do one more thing. Okay. I'm now going to solve for a squared. So I'm going to leave a squared on this side equals. Over on this side, I have a b squared. I'm going to have a plus c squared. I'm going to minus 2c, or 2b times c times the cosine of a. And that's my formula. Kind of pretty, isn't it? There's a few ways to write the law of cosines. This is the most traditional one. If you flip your notes over, this is what we get. Given ABC is a triangle with sides A, B, and C, then we know that this is true. And this is the most important formula. C squared is equal to A squared plus B squared minus 2AB times the cosine of C. Now for the test, I'm not going to make you derive that, but you should know how to do the law of sines or the area one. Those are straightforward compared to that one, right? Yeah, that one takes a while. Now look at your graphic organizer. Okay, I've got the formulas right for you there. See the first one, a squared equals b squared plus c squared minus 2bc cosine of a? That's the first one I showed you guys, right? That's the first one we wrote down. Most traditionally, the law of cosines is written as that. If you're trying to solve for side A, you could use the first one. Trying to solve for side B, use the second one. Side C, use the third one. If you're trying to solve for an angle, then you use the first, second, or third one. Now, these are not generally used. I never really saw these until I started looking at different books. Some students really like these. You can use whatever you want. You get this on the test. Okay? I'm going to always, always, always use one of these three. I will not use these in class. If you want to use them, go ahead. It's up to you. But this one I will use. And what it does is it helps us, again, find the missing sides. Now, all you have to do is identify which one of these 6 it is, and then just follow down here and follow the directions. So let's put this to practice and make it work. So we'll do an example, and you'll say, hey, wait a minute, that wasn't that bad. Solve the triangles given the following conditions. So I'm going to draw a triangle, A, B, and C. A, B, and C. Angle A is 26. Side B is 12. Side C is 15. Angle A is 26. Side B is 12. Side C is 15. Oh, I'm sorry. It's the idiot part of my brain doing work again. C is 15. A is 12. Okay. So, which of the 6 is it? Angle, angle, angle. Side, side, side. What's that? I heard you. Side, angle, side. Yep, you got a side, and included angle. So side, angle, side. So if you look at your notes tell you exactly what to do. We'll read the first part of it. Side, angle, side. It says, one solution. Use the law of cosines to solve for the missing side. Okay? That's where I'm going to start. Now, when you look at your triangle, all right, true or false? I have an angle on its opposite side. False. If we had an angle on its opposite side, then I could use the law of sines. So what we want to do is we want to figure out what side A is. In order that, we can use the law of sines. It's all about getting back to the law of sines, so that's quicker. So we should really only have to use the law of cosines once. And after that, we can use the law of sines. So I'm going to set it up. So what side am I trying to solve for? A. So I'll use this formula. A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So that's the first formula off your list. Okay. Oh, I forgot to say something. I think it's really cool. C squared equals A squared plus B squared. What's that? Yeah. The law of cosines is just like the Pythagorean Theorem. And it says, well, if you have a 90-degree angle, then you would just stop there. Because the cosine of 90 is 0. So this would all just go away. Or if you have less than a 90-degree angle, then it will subtract something off. If you have greater than a 90-degree angle, you'll get a negative value for cosine, and it will add something on. So you'll see it all happen. It's really cool. All right, let's go to work. What is a squared? We don't know. What's b squared? 144. Plus, what's c squared? 225. Minus 2 times 12 times 15 times the cosine of 26. And you could just type it right into your calculator just like that with your parentheses and everything, and you'll get a result for a squared. So type it in and see what you get. Let's do it all in one step. Just throw it in there. Bailey's ready to fall asleep on me. Your class used to be fun. Now it's boring, Mr. Gaines. Second square root, second answer. Negative key. A squared is 45 point. So your answer is a squared result. You have to square root it. You get a is equal to. So I go up to side A here. I got 6.74. Question. You messed your calculator up? Are you working in radians? Naughty, naughty Tyler. Stop working in radians. Isn't that what everybody's always told you? All right, okay. All right, now I need to help you guys understand something. This is going to be really important, okay? So you got to focus for about 5 minutes, and then the rest of it's going to go by real easy. True or false? You don't have to draw this. If you want to, you can. All the angles in a triangle must be less than 180 degrees. True. True or false? At most, a triangle can have one angle of 90 degrees or bigger. True. There can only be one obtuse angle in a triangle. That's it. Okay? So let's think about this really quick. 26 degrees. That's about right there, right? All right. Is cosine positive or negative in the first quadrant? Positive. So you can see as you're operating this, it takes 144 plus 225, whatever that result is, and it subtracts off some positive result to get a lower number. Let's say that it was 126. Is cosine positive or negative in the second quadrant? Negative, so it will subtract off a negative result, so it will add on an additional amount to create a larger side because you have a larger angle. Okay, does that kind of connect? Well, to some degree, you don't have to do it. I'm just trying to help you guys understand. Cosine can be positive or negative. Okay, so cosine is positive here, it's negative here, whereas sine is positive here and positive here. Okay, so that's a little bit difference with the law of sines, the law of cosines. Now, if I know that side A is 6.74, and I want to solve for angle B and angle C, what can I now set up? The law of sines. Watch. All right, so I'm going to use angle 26. Everybody agree? And I'm going to use 6.74. Everybody agree? Now watch, if you choose to use 15 or you choose to use 12, either way you're going to end up with a side-side angle situation, right? And when you get side-side angle, that's donkey, right? It's big problems. But we can avoid all those problems. We can. We can. I'll show you how. It says side angle side. One solution, use law of cosines to solve for missing side. When you use the law of sines, that's the step we're at right now. In order to find one of the missing angles, start with the angle opposite the shorter of the two sides. So look at your drawing. So now I'm going to use the law of sines. Will I choose to use angle B and side B or angle C and side C? B. And you'll see why when we actually do it. So I have the sine of 26 divided by what? 6.74 equals the sine of B divided by 12. And you get the sine of B is equal to what? 0.78. Pause. Hold on. We'll inverse in a second, but watch. Sine is equal to 0.78. Where is sine positive? First quadrant, second quadrant. So how do you know whether to use the acute angle or the obtuse angle? We decided. Look. If B is smaller than side C, so C is true or false? If side C is the largest, if there is an obtuse angle, it would have to match with C. True. So true or false? B must be acute. It has to be acute. So therefore, we can make sure that we choose the smaller of the two angles. So let's inverse sine B. What do you get? (51.26 degrees). We know that that's acute. It has to be, because you can only have one obtuse angle. And if there is an obtuse angle, it's going to be C. Can I now find angle C? Won't even matter. If you're given an obtuse angle right away, it doesn't even matter. Okay? How about, what do you get for C? There you go. All right, what do you think of that? Yeah, you got it. No. In the homework from yesterday, we just don't know. There's two possibilities. Remember, in this problem, you're given side-side angle at the beginning, right? And side-side angle says one solution. That's congruence that you know. Here's the problem, Vandy. If you would have tried to do angle C instead, you would have come up with a result that didn't work. Like when you checked your answers, you would have come up with angle B being the largest angle, but not having the largest side. It would have worked out funky for you. Unless you checked your answer, you wouldn't have known that. So I'm trying to save you guys from that scenario. Okay? So there is just one solution for side angle side. But yesterday's assignment, you had side angle, two possible solutions many times. Okay? All right, let's check another one. Here we go. What's different about this one? Three sides, A, B, and C. A is 10.5. B is 9.1. C is 12.4. I listed off. A, B, C. Is, we don't know any of the angles. Oh boy, it's going to be hard. 10.5. B is 9.1. C is 12.4. Ugh. Okay, look at your graphic organizer. There it is. Which of the six is this? Side, side, side. Read your directions. One solution. Use the law of cosines to solve for a missing angle. Okay? There's two ways to do this. Just look at the bottom one. It says just start by solving for the angle opposite the largest side. So this one, smaller side. This one, largest side. Why? True or false? If there's an obtuse angle, it must correspond to the largest side. True, and we're going to force it out. Sine doesn't know necessarily if you have an obtuse angle, because sine's positive in an acute angle, and sine is positive in an obtuse angle. But cosine is positive and negative, so it has the ability to determine, and we could go to work there. So let's show this thing worked out. Which angle should we solve for? C. C is opposite the largest side, so that's what I set up. So here's my formula. C squared equals A squared plus B squared minus 2AB cosine of C. Get your calculators ready. What's C squared? What's 12.4 squared? 153.76 equals, what's A squared? Cody's our speaker. 110.25. What's B squared? 82.81 minus, what's 2 times 10.5 times 9.1? 2 times 10.5 times 9.1. Okay. Here we go. That's what we got. Now what we're going to have to do is we're going to have to subtract the 110, we're going to subtract the 82, then we're going to have to divide off the 191. In fact, we're going to have to divide off a negative 191. So if we take out our calculators, I'll take out mine too. Okay, here we go. 153.76 minus 110.25 minus 82.81 equals negative 39.3. So I got negative 39.3 is equal to negative 191.1 times the cosine of C. Divide both sides by? Yeah, so you get 39.3 divided by 191.1 equals cosine of C. Very good. Now, watch. Is this positive or negative? Positive. Is cosine positive or negative in the first quadrant? So the angle must be acute. So the largest angle is acute. So is there an obtuse angle? No. If this was negative, is cosine positive or negative in the second quadrant? Negative. Angles are obtuse in the second quadrant, correct? So if it was negative, then you would have an obtuse angle. And cosine would show you that. So let's just inverse. Okay. We'll do second cosine inverse of 39.3 divided by 191.1. And we get 78.13. Now, watch this. I'm going to do the same entry, and I'm going to go back up here, and I'm going to insert a negative. Just so you can see. Let's say it was negative, then it's 101.87. So cosine's able to determine what the obtuse angle would be. Sine can't do that. Cosine can. Interesting. All right, so you got 78.13. I got to find A or B. True or false? A or B could be obtuse. False. They can't be obtuse. The biggest angle is C because it's opposite the largest side. So therefore, these are both going to be acute. So we just have to use the law of Sines. So we take the sine of 78.13 divided by 12.4 is equal to the sine of B divided by 9.1. What does Bailey not know? As long as you follow the directions on the graphic organizer I gave you, you don't have to worry about it at all. But for those who want to go deeper in their mathematical knowledge, so I get 0.718. I have to inverse sine that, right? Because I'm solving for an angle. Sine inverse of my answer, and I get 45.90. How do I find A? From $55.97. That's it. You guys, you got all day tomorrow to work on your assignment. Yeah. Because I didn't get this far with the other class. Why didn't I? No, I didn't tell them a story today. What? No. Oh, I had to go over an example with them in class. That's why I didn't get there. I didn't tell us. I don't tell stories. Yeah. Okay, so you got no. Okay, you guys, 9 through 14, you're solving the entire triangle, whereas 3 through 6, you're just solving for either an angle or a side. That's it. So 3 through 6, don't solve the entire triangles unless you want to go further and deeper into your mathematical capabilities. I warned you guys not to do that. I specifically told you, Billy Bar. You were sleeping in my class. Whatever. Bye, you.